Hey guys, so today we'll start the lesson off with a bell ringer. You are going to simplify root 3x plus root 27x minus 4 root 51x. So go ahead, pause the video, work through it. Whenever you're ready for the solution, unpause the video. So when simplified, this will be 4 root 3x minus 4 root 51. Now we couldn't split up the 51x. We couldn't split up the 51 because it was only 3 times 17. There's no pairs, so we just have to leave it as root 51x. So we'll start off today by talking about rationalizing denominators. Now we've done this a little bit in the trig section. Rationalizing a denominator involves rewriting a radical expression as an equivalent expression in which the denominator no longer contains any radicals. So we don't want any square roots in the bottom of our fraction. So in the example we have 1 over root 3. So if we multiply 1 over root 3 by root 3 over root 3, which is, as the note says, just 1, so we're not really changing 1 over root 3. I multiply across the top, across the bottom, I get root 3 over root 9, which is just root 3 over 3. So let's get an example. We have 15 over root 6. I don't want that root 6 in the bottom, so we'll multiply it by root 6 over root 6, which will give me 15 root 6 over 6. Now I can reduce 15 over 6, which will be 5 root 6 over 2. Now I just reduce 15 over 6 by dividing the top and the bottom by 3. Next one I have 12 over root 8. So I multiply the top by root 8 and the bottom by root 8. I get 12 root 8 over 8. Reduce 12 over 8 to 3 root 8 over 2. Now, I can also take that root 8 and reduce it, so let's look at 8. I can split that up into 4 and 2, and I can split the 4 up as 2 and 2, giving me a pair of 2's. So I have 3 times 2 root, and we have a 2 left inside, over 2, allow me to cancel out my 2, so it's just 3 root 2. So, go ahead, work through this huddle by rationalizing the denominator. Go ahead and pause the video. When you're ready for the solution, unpause it. So the two solutions are 5 root 3 over 3 and root 3. So sometimes when we have square roots in the bottom of a fraction, they have something added onto it. So in the case of the first one where we have 5 plus root 3 in the denominator, multiplying by root 3 over 3 is not going to rationalize it. So we need to be able to multiply by something that will get rid of that 5 plus root 3. Well, we do that by multiplying the conjugate. And all the conjugate is I take this sign, instead of a positive, I make it a negative. So I multiply 7 over 5 plus root 3 by 5 minus root 3 over 5 minus root 3. You'll see in the examples what's going to happen when we do that. So whenever you have the sum of a square root in the bottom of a fraction, you multiply by the conjugate. And then we have a couple more examples that you can take a look at of what multiplying by the conjugate will look like. So in the first example, I have to rationalize the denominator. So I take 2 over 3 root 2 plus 5. I don't like that root 2 in the bottom, so I'll multiply by the conjugate of 3 root 2 plus 5. So I will multiply by 3 root 2, change that sign to a minus 5 over 3 root 2 minus 5. And okay, again, we're allowed to do this because I have root 3 root 2 minus 5 over 3 root 2 minus 5, which is just 1. So I'm not really changing anything. So my numerator I have 2 times root 3, 3 root 2, which is 6 root 2, minus 5, 2 times 5, which is 10, over the product of my denominator. Since these have 2 terms each, I'm going to use the box method to go ahead and multiply these. So I have 3 root 2 and a 5, 3 root 2 and a minus 5. 3 root 2 times 3 root 2 is 9 times 2, which is 18. Then I have minus 15 root 2, a positive 15 root 2, and then a negative 25. So my denominator will be 18 minus 15 root 2 plus 15 root 2 minus 25. Now, here is where multiplying by the conjugate helps. If you notice, we have a negative 15 root 2 and a positive 15 root 2. Well, when you add those together, it will cancel out, leaving us with a 6 root 2 minus 10 over 18 minus 25. Give us the final answer of 6 root 2 minus 10 all over negative 7. So there is my final answer. The next one I have 8 over 4 plus root 5. So I'll also need to multiply by the conjugate. So this will be 4, change the sign, so minus root 5 over 4 minus root 5. Multiply the top, I get 32 minus 8 root 5. And to multiply the bottoms again, I'll have to use the box method with a 4 and a positive root 5 and a 4 and a negative root 5. Again, if you can just double distribute these, you don't have to do the box, but the box helps, use it. So that'll give me a 16, a negative 4 root 5, a positive 4 root 5, and a negative 5. So in my denominator, I have 16 minus 4 root 5 plus 4 root 5 minus 5. Giving me 32 minus 8 root 5. Cancel out the negative 4 root 5 and the 4 root 5, giving me 16 minus 5 in my denominator. Therefore, give me the final answer is 32 minus 8 root 5 all over 11. So here we have the definition of the principal nth root of a real number. And it says if we have the nth root of a that is equal to b, means that b to the power of n is equal to a. And if n, the index is even, so the nth root or the power of n is even, then a is non-negative or it is greater than or equal to 0. And b will also be non-negative or greater than or equal to 0. But if n is odd, a and b can be any real numbers. And that gives us the ability to find nth roots of perfect nth powers. So if n is odd, then the nth root of a to the power of n is just a. However, if n is even, then we have the nth root of a to the power of n equal to the absolute value of a. So that's saying odd powers and odd roots can give us positive or negatives, where just the even powers give us the only positives. So here are some of the roots that we might be dealing with. You have your cube roots, your fourth roots, your fifth roots. So these will be helpful if you don't have a calculator. You can take a look at these to find your cube roots, your fourth roots, your fifth roots, and stuff like that.